Video we are going to discuss Leetcode's problem of the day. So basically the name of the problem is count number of nice subarrays. Basically what the problem statement says, let's read. We have been given an array of integer nums and an integer k. Okay, we have been given an array which is nums and an integer k. Okay, a continuous subarray is called nice if there are k odd numbers, means k mod 2 not equals to 0. Okay, so basically we have to return a number of nice subarrays. It's a pretty simple problem. Just what we have to do, we have been given an array. Yes, we have been given an array 1 2 3 4 for example. So in this array we have to find the total number of subarrays, nice subarrays, in which there are k odd numbers. For example, here our k is what, 1. So our nice subarray will be what, 1 is also a odd number. This, yes, this, because 3 is also odd number and 1 is also odd number. Yes, so basically what we have got are two subarrays. Okay, so these are our subarrays. Also there is one subarray. Yes, this one. Yes, so by this we have got our three subarrays. So in this way we have to solve the problem. Just we have been given the array and we have to just count the number of odd numbers and then print the total number of subarrays which can be formed. So now let's discuss our first example. Okay, we have been given our nums equals to nums array. One, one, two, double one. Yes, one, one, two, double one. So this is our given array and our k is equals to 3. 3 means our k is equals to 3 means must be at least there must be at least 3 odd numbers. No, sorry, there must be at most 3 odd numbers in the array. Okay, means ज़्यादा से ज़्यादा 3 odd numbers रहने चाहिए array में. Okay, means ज़्यादा भी नहीं कम भी नहीं, 3 से ज़्यादा भी नहीं 3 से कम भी नहीं, ऐसा. So this so in how to find the number of sub arrays here, basically 1 1 1 2 1 or 1 is wait a minute. Yes, or 1 is basically what, odd numbers. Okay, this is our odd numbers and now we have to find the total number of sub arrays containing 3 odd numbers. So it is 1 1 2 1 and 1 2 1 1. Okay, so this is our total number of sub arrays, which is 2. Our answer is what, 2. Same for this only. Let's talk about example 2. What our num is given 2 4 6 and our k equals to 1. K equals to 1 means there must be at least one odd number in each sub array. Okay, so as you can see that any in this sub array there is no odd number, so our output will be just 0. Okay, means if there is no odd number, so there will be no sub array formed, so our output will be just 0. Okay, now let's talk about a bigger example, a bit difficult one. Not we can't say it as difficult. Okay, just a lengthy one. Our nums equals to 2 2 2 1 double 2 and 1 triple 2. this is our nums or k equals to 2. Okay, so basically what, basically we have to give the sub array containing at means two odd numbers. Okay, we have to give the total number of sub arrays which can be formed containing two odd numbers. So in this you can see there are two odd numbers, 1 and 1. Okay, these are the two odd numbers. So how many sub arrays we can form from here? Okay, wait a minute. Yes, so basically now let's try to form the number of total number of sub arrays. Okay, so basically what we have to find, must have two, at least two odd numbers. Okay, so our first sub array will be our first sub array will be 1 2 2 1. Okay, then 2 1 2 2 1, then this one, and then this triple 2 1 2 2 1. Okay, so this is our sub arrays. Okay, we have got here our first sub array will be what, 1 2 2 1. Now let's write it. First is 1 2 2 1, second is 2 1 2 2 1, third is what, 2 2 1 2 2 1. Okay, and then fourth is 2 2 2 1 2 2 1. So these four arrays we have got here. Okay, now let's go on another method. So left side one has been completed, now right side one. Okay, so basically this 1 1 2 3. So we have got three sub arrays. Now again three sub arrays we have got here. Okay, now let's note it down. Our fifth is what, 1 2 2 1 2. Our sixth is what, 1 2 2 1 double 2. 1 2 2 1 double 2. Okay, now our seventh one is 1 2 2 1 triple 2. Okay, so up till now we have got our seven sub arrays. Okay, as you can see here we have got our seven sub arrays containing all, as you can see all contains 1 1, 2 times 1. Okay, each sub array is containing at most two odd numbers. Okay, as you can see in this example I have shown. Now let's move on to another method to find the sub arrays. Okay, now let's what we can use now. Yes, now let's go on to some another one, means this one, a whole array. Okay, then this one, wait a minute, first one, then second one, then third one. Okay, so in this we have got three sub arrays. Okay, as you can see three more we have got. So now let's add it to here. Our what will be our 81, mm, first 2 1 2 2 1 2, okay, 2 1 2 2 1 2, okay, then ninth one, double two, or ninth one, double two 1 2 2 1 2 2, okay. So this was our ninth one, and now tenth one. Tenth one, as you can see here, what's this, triple two one two two one triple two, okay. So this is our tenth one, triple two one double two one triple two. So this is our 10 sub arrays. As we can see that we have got up till now 10 sub arrays, okay. So now let's see another one, okay. How many sub arrays we can form here now? I've got more another one method, okay. Yes. So in this, as you can see in this array, at index 2, at index number 2, okay, you can see that one beside the 2 on the left side, this one, wait a minute, from this one, okay, from this one, what we can do here, now move on to the left side. As you can see, we can go on here from this, then we can go here also, okay. These two sub arrays we have got here now, as you can see here, but this blue one, as you can see, already we have taken this blue one, so we will not count it, okay. You must be able to see this blue one, okay. This we have already taken, so we will not count it, we will count the new two ones. So two more sub arrays we have got, okay. Wait a minute. Yes. So now another two sub arrays, this one. So it is this one, and then the last one, okay, as you can see, and then at last this one and this one, okay. So as you can see here, we have got our another six sub arrays, okay. The orange one, the brown one, and the pink one, as you can see here. So we have got our six sub arrays. Now let's note it down, our 11th sub array. What's our orange one? 2 1 2 2 1 double 2, 2 1 2 2 1 double 2, okay. 2 1 2 2 1 double 2. As you can see that we have got our 11th one, now 12th one, 2 1 2 2 1 triple 2, okay. Our 12th one, 2 1 2 2 1 triple 2, Yes, we have got our 12th one also. Now 13th one. Okay, 13th one will be our brown one. Double two one, double two one, two. 13th one is in brown color. Double two one, double two one, two. Then our 14th one. 14th one. 14th one will be double two one, double two one, double two. So we have got 14th one. Okay, sorry, there was a mistake. It's not, there must be one more two. Okay, so now last one, pink one. Okay, we are taking the pink one. So on the left side I am going to show you the pink one, this and this, these two pink ones, as you are able to see on the left side. Okay, these two you are able to see, these are the pink one, and this will be our 15th and 16th. Triple two one, two two one, triple, which is our one. Yes, this is our 15th one, and next 16th one. Triple two one, double two one, double two. Okay, so this 16th, so our output will be what? 16. As you can see, I have shown the all 16 sub arrays. Okay, this from 1 to, these arrays are from 1 to 10, and then 11, 12, 13, and then 14, 15, and 16. And this is our given array nums. Okay, so in every sub array you can see there is 1 and 1 common, irrespective of the number of twos, but there is one common. Okay, so how can we use this, how can we find the total number of these sub arrays? Okay, we have to use a special technique here called hash map. Okay, we have to use hash map here. So now let's use the hash map. We have to first of all transform. First we have been given the nums. For example, our nums is in this form, this integer form. Okay, so our nums is in integer form. So now we have to convert it into binary form. Binary form means, for we will use 1 for odd numbers and 0 for even numbers. Okay, 1 for odd numbers and 0 for even numbers. So our new sub array will, new array will be 1 0 1 0 1. Okay, this will be our new array. Okay, then what we will use, we will use prefix sum array. Okay, what we will use, prefix sum. Okay, to oppose to means to keep the track of number of odd numbers encountered up to each index. Okay, then we'll be counting the sub arrays with exactly k odd numbers. It is used to find the sub arrays with exactly k odd numbers. So we will use hash map or dictionary here to store the counts of prefix sums. This helps us to determine the number of subarrays that end at a particular index and contain exactly k odd numbers. Okay, so let's draw our hash map here. Hmm. We have got our hash map here. Yes. So now let's try to solve the problem. Okay, let's try to solve the problem with the help of code. Okay, we will with the help of code, and now and afterwards we will discuss the time complexity. Okay, as the sub means its time complexity and space complexity are simple of and only, so no worries. Yes, first I have first of all I will convert the odd numbers to 1 and even numbers to 0, means in binary form. 1 if num modulo 2 equal to 1, means odd number, else 0 for num in nums. Okay, so now our array is converted into binary form. Then we will use prefix sums, initialize prefix sums. We will use dictionary here. First of all we will initialize 0 and 1. Okay, we have initialized here 0 and 1. Then our current sum is initialized to 0 and our result is now also initialized to 0. Then we will iterate to for loop for num in nums, means we are checking for each number, means each element from the nums of nums array. So our current sum plus equals to num, means we are going on iterating, means incrementing the current sum by each num. Okay, for each iteration. Okay, then we will check if there exists a prefix sum that when subtracted from current sum gives k. Okay, if current sum minus k, if it is in prefix sums, if it is in prefix sums, okay, then we will increment our result by what? By a prefix sum of current sum minus k. Okay, then we will use another if statement. If our current sum, if our current sum is in prefix sums, if it is in prefix sums, okay, then we will what? Then we will initialize the hash map. Okay, we will initialize the number of elements in the hash map. I will explain each and every point after the writing of the code. Yes, then else statement. If it is not in prefix sum, then we will just initialize it to 1. Of current sum. just initialize it to 1, and then at last we will just return our result. Okay, now let's try to run the code. It's giving some error, current sums is not defined. Okay, okay, yes, now it's okay, it must run now. Let's fix. Yeah, it's giving correct output now. So now let's discuss the problem statement with the help of the approach. Okay, first of all, let's suppose this binary number we have used means for example, let's suppose we have taken example 1 only. Okay, our nums is what, 1 1 2 1 1. 2 1 1. Okay, and our k is what, 3. Okay, so this is our basically the problem statement. According to the code, how we will solve it. Okay, first of all, our binary array will be what, 1 1 0 1 1. Okay, this is our binary array. Our prefix sum is 0 is to 1, and our current sum is initialized to 0, and result is also initialized to 0, this one. Okay, as you can see, so all we have done here. Now we'll iterate to the array for index 0. Now we are at what, index 0. Yes, first we are at index 0. So for index 0, what, or we will update the current sum to 1. Okay, our current sum will be what, current sum will be 1 here. Okay, as you can see, so our current sum will increment to 1. Is that clear? Our current sum will increment to here. Now we will check. Now we will check if current sum minus k. If current sum minus k is what exists in the prefix sum. Okay, in this in line number 11 you can see if current sum minus k in prefix sum. We will check if exists in prefix sum, means 1 minus k is what, k is given a 3, so 1 minus 3 equals to what, minus 2. So it does not exist in the prefix sum. Okay, so now we will go to current sum. If current sum is what, current sum is 1, another if statement, 14 line. If 1, if current sum in prefix sum, means this one exists in prefix sum, then we will increment the current sum by 1. Okay, now we will store here. We have got our 0 as 1 and 1 as 1. Okay, these are integer, these are basically the count, and this is int. Okay, we have 1 0 and 1 1 up till now, as you can see here. Okay, what is k? 1 1 minus 3. Okay, so we have got minus 2 here. Okay, and our hash map, this is our int, and this is our count. Okay, so as you can see here, now we will move on to another iteration. Okay. Hmm. Now we will just go on to another iteration, iteration 2. Then for iteration 2, our current sum will be what? Our current sum will be 2. Okay, now what? Wait a minute. Now our current sum is 2. So 2 minus 3 is equals to what? Minus 1. We will check if minus 1 is in our prefix sum. Okay, if minus sum is in our prefix sum, so we will increment. As you can see that minus 1 does not exist. Okay, minus sum does not exist here. So we will update the prefix sum by 1. Means we will, the current sum is what? 2 now. So it's 1. Okay, this is basically what? Our current sum. Current sum. Okay. Now hmm, hmm. Now what? Now we will go on iteration 3. Okay. Now its value is 0. Our current sum will be what? Current sum will be 2 plus 0 what? 2 only. Okay. Our current sum will be 2 only. So 2 minus 3 equals to minus 1. So again our as you can see that it does not exist. So we will just, what we will do, wait a minute. So again we will increment. Now what we will increment? Our current sum is 2. So just we will increment the current sum. At index 3 we have got our current sum as 2 only. So it will be now 2. Okay. Now what we will do? Now we will iterate on index number 4. Okay. So next iteration, then what will it will be done? 2 plus 1. Our current sum will be now 3. Okay. What will be our current sum? 3. So now 3 minus 3 equals to 0. Okay. Current sum minus k is what? 3 minus 3 equals to 0. Is that clear? 3 minus 3 equals to 0. So now we have got 0 as answer. So 0 already exists in our list. Okay, in our binary number 0 already exists. So we'll increment our result to 1. Okay, our result will be current sum minus k. Current sum minus k is what? 0. At 0th index, what is present? 1. So our result will be incremented by 1. Now our result is 1. Then iteration, then another iteration 4. What's our value? Value is 1. Last one. So last one. Our current sum will be what? Our current sum will be 3 plus 1 equals to what? 4. Okay. So now 4 minus 3 equals to what? 1. Okay. Current sum minus k equals to 1. So 1 already exists in this list, as you can see. 1 already exists. So our result will now again increment by 1. So our result will be 2. So in this list, as you can see that 3 came for one time, our current sum 3 came for one time and 4 for one time. Okay, this 4 has came for one time, then 3 has also came for one time. So basically this is our hash map technique, and now we have got what? Our result equals to 2. So this is our final answer. Now I think you have got the my code and the approach. Okay, let's try to submit it. Yes, you can see that it's been accepted. So thank you friends. If you have any of the doubt, you can ask me in the comment section. Okay, so thank you very much. Like and subscribe.